I'm Ivan. I've been working with Derivative for a little over 10 years now since they brought Python on. And I've been, kind of the team Python wizard, or Greg has called me the Python police from time to time. So I'm gonna do a lightning fast from nothing. I was told there'd be some beginners here. So I'm gonna go from nothing to your own callback system in 20 minutes is that's what I'm gonna try to do here. You probably wanna make the view full screen so that you can read the text because there's a lot going on the screen, and there's a fair amount of code involved. So yeah, let's get started here. So first, starting from the very beginning, we're just going to talk about all the places where we use Python in TouchDesigner. And so the first place that probably everybody will use very quickly is in parameters. We have expressions. So as you can see in the blue expression mode, you can just type in some math. So 1.3 is 4 up here. You can reference other things in TouchDesigner. So me.par.tx is another parameter. So this second parameter is looking at this first parameter. And when I change one of them, the reference changes the others. And that is called a dependable data, meaning that things update automatically when they're looking at each other. We'll go back into dependable data, go deeper into that in a little bit. And then in this last parameter here, we have math. There's a library of math functions, the cosine function, and again, looking at a parameter. So all of this is Python code. So you can run Python right in the parameters of your objects. That's the most basic level. You can also write straight scripts. So the other place we use Python is you can just write Python code right into a DAT here. And you can see this very simple bit of code. So this tells this operator's Y transform parameter to move up a little bit. And so you can right click on this script and run it. And it's going to move the little graphic up here just a little bit. It moves the noise up. And you can run that from other places in TouchDesigner. So you can just have basically a little Python program in a DAT. The third place we use Python in TouchDesigner is in callbacks, and that's another very common use. You've probably used them. You'll see them in various execs. Here's a chop execute, par execute, dat execute. So we'll just take a quick look at this. This chop execute here has these functions in it. These are functions that are called by TouchDesigner when certain events happen. And so you can tell it's a callback. We always name them with on. So on the event, off to on. So that's on a certain event. And sometimes you'll see callbacks with the while on it. So while on, so every frame while this certain thing is true, while this channel is on in this case, it will run this. So let's just see how that works. It's looking at this channel on the chop here. So here, let me move the screen a bit here. So watch this noise. When I turn the channel on, it's going to keep moving that transform up again, a little bit like the code that we wrote in script. And so that's a callback there. Certain operators in TouchDesigner will have callbacks that drop them. So when you create this timer chop, it's going to come with this docked node that has inside of it, again, I'll put it in the text port. It has inside it a bunch of callbacks that are reactions to things that happen with the node. And there's all kinds of execute stats, all of which have callbacks in them. And so we'll be also going back into callbacks later in the presentation here. And then the fourth place we use Python is in extensions, which I'll go much more deeply in the next example. First, just a few words about when to use Python versus when to use nodes, because you can do pretty much anything in Python. But when are nodes better? Nodes are mostly better because they're so fast. So if you're doing things that require maximum speed, you pretty much always want to do it in nodes. And the secondary advantage of nodes is you can see data kind of transform when you wire them together. You can see a visualization of the changes in your in your textures, in your 3D objects, and you can see the chain of nodes changing. Python is a little more invisible. It's all happening. And so you'll have to, use debugging techniques to find out what's happening in there. So data visibility is very nice in nodes. And so when is Python better? Python is generally better for complex logic operations, structured data, like in JSON, you have objects with objects, and you want to deal with a lot of complex data, you'll want to use Python. If you want to use external Python libraries, there are a million of them. They do tons of amazing things, and you will want to use external Python libraries. You have to be using Python to interact with those. You can integrate all those amazing features that other people build for you. And then the other thing you always want to use Python for, this is the only way to do it, is want to manipulate and create TouchDesigner objects like operators and parameters. If you want to have a thing that generates operators or adds parameters to operators, that has to be done in Python. So if you want to go further, there's lots of examples of Python. If you go in here in the help menu, you can go to Python examples, and there's a whole network of tons of examples of how to do various things in Python and TouchDesigner. So that's the basics of where we use Python and TouchDesigner. Zoom out here. Before we go to the next example, I just want to give you a few tips if you are a beginner in using Python. And this one is just a general TouchDesigner tip. Just make a folder for when you have a new project. Make a folder to keep your TOE file in, and then you'll keep all of your external resources in a specific folder for your project. And then in that folder, it's nice to keep your Python in a dedicated folder for your Python, and you can have more folders within that if you need to. We usually call that folder scripts. And so if you keep all your Python in one place, it's nice, especially when you start using an external editor, which is our next point here, is that you should use an external editor. They have lots of great features. We usually work with VS Code. I've been building features specifically for VS Code. So if you use that, I actually use a fork of VS Code called Cursor, which has better AI integration. And so I recommend using that editor, and you can make a workspace for that. It helps a lot, and we'll give you some nice code completion. Talk about that more in a second. The debug command, when you're debugging your Python scripts in TouchDesigner, you'll want to print out stuff that's happening in there in certain events, and you can use the print statement to send out data from your script so you can see what's happening. And this tip is use the debug statement for that instead. It's almost exactly like print, but it also tells you where your print came from, which will save you a lot of time when you forget about it somewhere in some obscure DAT and you don't know why things are printing to your text port. If you use the debug command, you will know where it's coming from. And then if you want to use more advanced debugging, if you want to, say, leave something running and then you want to look back later and see what's been happening with it instead of working with it, and watching the text port, there's a logger comp in the palette, which has a lot of great features for printing, for basically doing stuff like a debug statement, except send it to a file, and you can do kind of more advanced logging features using the logging library in Python. and this logger component integrates that nicely with TouchDesigner. And then we have this very new feature in the current experimental, and later we'll have the TDI library, which does a lot of code completion for you and will tell you about TouchDesigner objects. It's aware of all of the operators and the parameters on them, etc. The TDI library will help you when you're coding using VS Code. And I won't go deeply into how to set that up, but it's in the wiki. So definitely use that if you're using the experimental version. Okay, so let's quickly take a look at extensions. And I'll share this file in the chat later. So if you want to look through this again, I'm going pretty fast, so it'll be there. So extensions, what extensions are is basically they let you, when you create a custom component, so this is your own component that you can put custom parameters on. It lets you build a Python interface to your custom component. So we're just going to set up this. I'm going to set the poorly named variable a to this operator. And so I've given my operator a Python function. So I can now just tell the operator random color, and it changes the color of the operator. And so we'll take a quick look at the extension. Inside of it, there's a dat file. Whoops, sorry, that might not have been clear. I went into my operator here. There's an extension file, and inside of that extension file, I basically just created a function here, random color, that changes the color of the thing. And there's a bunch of other features here. Basically what this silly example does is it's a button that shrinks and then reappears. And so all of that is done by the extension and the other machinery in the component. And so let's talk a little bit about the advantages of putting extensions on your components. One of the big ones is all your Python is integrated into one place. So here, let me open up a floating window here. Oh, I hope you can see this. Actually, here, I won't do it that way in case you can't see it. I'm not sure how the interface works here. So let's just go inside here. So inside is all this machinery. And you can see that I have these 3 different execute dats, or 2 execute dats and callback dat, all of which have Python code in them. And so rather than spreading all of your functionality into these dats, you can kind of send it all into your one extension. So just as an example, let's look at what's in this dat here. It has a bunch of reactions, and what I do is I send it extension, so you can send to my shrink button ext extension. You can send this on to off, and what that is telling me is that the button was pressed. So I send it to my on button press, which you can see I've named this as a callback. This is an internal callback that I've created here. And so then in my extension here, on button press, here I do something very simple, but point being that I put all of my reactions in the code of the execute dats, but then any of the things that I actually do with those events in TouchDesigner, I put them all in the extension so that it can all be in one. This is much easier to think about for me anyway, so that's a good one. The second advantage of extensions, which I've kind of already showed you, is that you now have a Python interface that other users can use to your component. So like I showed you this example of the random color function. So you can now call Python commands that are made to affect your component. And then the other thing is there are dependency and storage tools. This is a big subject. I'll just very briefly show you what's happening here. I've created a property on this called test dep, and that's a dependable property. And I've also put some stuff in storage. Things you put in storage are saved with your file. So I've put my color into storage, which means the color will be saved with this file. And when I open it up, it will be the same color. Just quickly, let's take a look at, whoops, I've done something terrible. Oh, yeah. Okay. So let's take a look at what dependable data is, because it's an important concept with TouchDesigner Python. So my shrink button here, it has a variable on it called test. Okay, it's got the number 5 in it. When I change this variable called test to 6, this is not reacting. And I've just created test here as a regular variable. It does not, the parameter here does not automatically update when I change. But I've made this other variable using the create property function here called testDep. It's a dependable test. And I set dependable to true over here. And so you can see in this comp over here, I'm looking at this test dependency. And so I'm going to change the test dependency. So mind you, I'm changing it in Python. And when I change it, it updates this parameter automatically. A lot of times you will want your data to be accessible by parameters and change when it changes inside of. And you need to do that little bit of extra legwork. Very important concept. You can go deeper. There's stuff in the wiki about this. Okay, so before we move on from extensions, I'll just talk about a few techniques. Most basic, you use the component editor to create extensions. So when you drop any component, you can customize component. In the component editor, you go into this extensions tab, and you can make an extension, type a name. And, you can't see the editor. Okay, well, you'll be able to figure it out. Use the component editor to create your extensions. When you use it, what it does is it fills out your extension parameters for it. You can also do this by hand, but the component editor is what you. So yeah, it will fill out this parameter for you, and it will make you a nice extension dat with some stubs. Let's take a look at that. So it will create an extension with some nice stubs to show you kind of how things are done. This storage stuff that I showed you, and an example create property for dependable data. So anyways, that is how you'll want to create extensions with that. Another technique with your extensions is it's really great to make parameters to access your key features. So just in my example of the shrink button, I made a random color function. I also made a pulse button that just calls that function. And so when I push it, you can see I can change the color with this. This is great for testing, because if I want to test my random color function, I can come up here and very easily do it, and I don't have to type random color in the text port every time. We talked about this already. Use create property to make dependable data, like I showed you, and also use the storage manager to make savable data. And I won't show you an example of that, since data stuck on your components that saves, and also if you cut and paste, your extensions will restart and go back to their default states. So if you want to save stuff through cutting and pasting or saving and reloading, you'll want to use this little bit of storage manager code in order to do that. Okay, that is the super fast introduction to extensions. So let's talk about custom callbacks. So like we talked about, there's many TouchDesigner operators that, you probably can't see this window. That's all right. I'm going to make a timer chop here. So when you make a timer chop, as we looked at before, it has callbacks attached to it already, which gives users a nice interface for interacting with events within the timer chop. And so what if you want to do that for the code for that can be a bit tricky, especially if you're a beginner. And so inspired by this, I actually have made a new component here that will be coming out in the next experimental release. And you will have a very early version of it in the set. This callbacks helper component. And what you can do with your custom component, I have our same button here that we had before, the old shrink button. And I want to call back so that the user can do something when the button shrinks all the way down. And so I would like a callback. So in order to add callbacks to your shrink button, here, let me do that slowly so you can see that I'm going inside the shrink button. I'm going to paste the callbacks helper component here. And on the callbacks helper component, there's a little bit of information, and basically you can just click set up callbacks. And we'll go back to the outside, and you'll see that this has made a little callback stub here. We'll look at that in the text port. It's got an on-test callback built into it. And so what I've done here is I've given the shrink button the ability to have callbacks. And I'll just quickly show you. We'll reset our poorly named variable A to this shrink button. And so now A now has a new function on it called do callback. That's what the callback helper gives you. And you can run on test, the on test callback. And what that's doing here, let's take a look again at the code in the callbacks here. The on test code just does a debug statement with on test callback and the info that's to it. And so you get your on test callback, and you get a bunch of automatic the component that it's on and the callback name that was called. Let me show you, clear this so that's not so messy. So you can also send a dictionary of any other data you want with your callback. There it is. So now I'll do the callback again, and you'll notice that in the info now is this extra data. Here it is. So you can send whatever you want. So let's very quickly take a look at how you might want to use that. So we're going to go in here, and I'm going to edit my extension in there. And in my extension, I conveniently sent myself an on timer done. That means the shrink is complete. And I'm already calling the self reset size. That's why it shrinks and then So what I'm going to do is I'm going to tell it to do the on test callback when the shrink is complete. So now I've added the do callback command. And so now we'll go back to the text port here. And I'm going to press the shrink button, and notice when it's done shrinking, boop, we got our on test callback. And so why would the user want something like that? Well, for example, maybe I want it to also change the color when it's done shrinking. So from this info object in the callbacks, I have the owner comp. So that's the button itself. Owner comp.random color. Conveniently built our Python interface in the extension so that we can call random color on it. So now when I shrink the button, it comes up with a new color. So this is a very simple example of, but this is extremely powerful if you're building components that have events in them that you want your user to react to. And in the example file, I've done all this again. Here, sorry. Go into this complete example, and this has that already built for you, so you can see exactly how it's done. You can dig into the details of this. And so that's how you can, now with this new feature, very easily have a custom for your custom component. This is the conclusion of my super crash course from zero to your own callback system in TouchDesigner Python. Great, thanks. Can move on.
Amazing, thank you. Beautiful overview. Very fast, but
yeah. I you said there's going to be beginners, so I'm like, okay, I'm going from nothing to everything very fast.
No, it's great. It's a great overview. And the callbacks component you shared there, you said it's going to be in the experimental, or can we access that somehow?
It will be coming out in the next experimental. This presentation actually inspired me because I'm like, I got to make it easier for people to make a callback system. Many people are building their own. So for now, you can only get it from this file. You can copy it out of this file, and it will work. You can copy it. You can get the experimental, load this file, and then put it in the official release. It will still work. It'll complain the first time you load it. But then it'll be a standard. It'll be in the palette starting with the next experimental release.
Cool, thank you. Just one small tip about the like making extensions. Actually, like Dan's like function stores toolbar makes it very easy to create extensions for any component. So I can recommend that. I've been using that quite a bit.
Dan has incredible tools. I recommend using those as well. They're great.
Last meetup was about that. But yeah, thank you. And we're gonna move on to Wieland as our second presenter now.
And so I'm just going to jump right in. So the first thing that I have to do, of course, is do a little bit of what is PlusPlusOne? Who am I? So PlusPlusOne is a new company that I co-founded beginning of this year, and we combine AV tech for live events. So you can see two examples of projects we already worked on. So here we are doing the classical media server setup and media management, signal management using elements like items like Barco, Event Master, and Aquilon, you name it, all of the good stuff. And we combine this with bespoke interactive and immersive solutions. And this is primarily where we will, or where we are already actively using TouchDesigner. And we do the full road from conception over development, execution, and we also offer dry hire. So dry hire probably primarily if you are in Berlin or at least in Germany, but the rest certainly in the DACH region, but also everywhere else on the world. If you need us, you can just drop us an email, hello@PlusPlusOne, but you can also find us on Instagram, on LinkedIn, and on GitHub under the same handle, which is quite nice. And I'm going to also just drop this. We are having several POS projects that we are hosting and maintaining on GitHub, and we're super happy if other people are interested in joining, in contributing in any way. So there's some stuff that you might already see or know. So like the TouchCity preset system might ring a bell because I operated under the label of Alpha Moonbase for quite a while, but now everything is under the hood of the PlusPlusOne GmbH. And yeah, there's also like some very interesting stuff for Python. So we have Touch Utility Collection that I'm currently working on. We have some UV management stuff. We have like the TouchCity preset, TD async IO. So this is all stuff that we can definitely talk about later if you are interested in the breakout rooms. So I'm going to jump back to here. I'm going to make a little and bring me here in the bottom. I hope you can see me. Let's make me a little bit bigger. And now we will actually talk about the topic for today, which of course callbacks primarily, not even extensions, because I think Noah already has something to say about that, and Ivan also gave a very good introduction. So the first thing I don't even really have to talk too much about, but I will certainly show some little stuff that might be interesting. Why we are using callbacks, maybe a little bit more on that, is that we get very detailed and tight information. Because sometimes if you're trying to reset something and then you're trying to link it to the done channel, and you then have to sometimes create like a very long chain of operators to get just some basic information. But with the callbacks, we get a lot of information already for free that we can directly access quite easily. So for example, we get the segments as an argument. Ivan, I don't know if you can read this. It's now if we go into our text port, you can see here that we now get for every segment of our timer, we already get the meta information of like hello world and true for every segment that we are in. So we have like this very nice, clear and understandable chain of actions that we are looking at. Same basically again especially for the network element. On connect, on receive, on close, and it's very clear what's happening. We can, of course, try to go around this using an info chop. That would be one way to also check if something connects or not. But especially with the on receive, when we would use like a select that to only get like the last message, then sometimes we can miss out because when we just receive the same message over and over again, example, we wouldn't be reacting correctly. Another cool thing is that callbacks are also used to get information back in to an operator, because operators, contrary to components, are C++ in their core. So we can't go in and change any. Sometimes we want to at least adjust the behavior of an operator, and this is where callbacks also come in. So for example, I found here the OP find that, but the timer chop also does that, is that you can feed back information in a callback. So using the onFind OP get include, very nice name by the way, we are able to do a little filtering. So what we, for example, can do is we can say return core OP and is instance. We can ask for it to be a dat. And now with just this line of code, we change the behavior of the OP find dat, which is very nice because we can then use external data, different data from other places. We can work it and knead it a little bit to fit our actual needs. And we don't have to like go this whole way of like creating large unreadable operator chain nets. I think another thing that's quite interesting in callbacks is that you can reuse them. So if we just copy this timer here and we go to timer, then you can actually see that there is a parameter that is pointing to a specific dat. So we can just drop this one in here. And now we have one source of true for the behavior that we are giving out or reacting to the timer. And now if we change this timer, for example, then we still only have one entry point at least that we have to take care of. So yeah, callbacks and custom comms, definitely most important topic, I think, because I use it a lot. I don't use the system that Ivan or like TouchDesigner provides. I built a little small component called the callback manager, which behaves a little bit different because it's its own operator. So it separates a little bit the callbacks from the rest of the extension logic, because the way Ivan's setup is that if you change the operator, you reinitialize all of the extensions, which is okay. There are points where this is actually desired, but I found it to be a little bit distracting, especially if you have some kind of stateful extension. Then you suddenly changing the callback like reinitializes everything, which can be a little bit annoying. The way this one works is that you basically have, again, the do callback function, and contrary to the way it works with the derivative way, is that you define, like predefine the functions and pass them in as like the default parameter. And this allows us to define custom signatures, which are also typed. I mean, in this case right now, it's not really nicely typed because it's just a par, but still already this gives us quite a nice way of working with the arguments. Also, we can, of course, then in the default here just pass in custom info. So this is the default now, and if we now create our callbacks here, then you can see, okay, we have the custom info here. Why is this cool? We can create dynamic callbacks. So in this case, for example, it's the par exec compose. So it's just a wrapper and around an existing operator, but just making it a little bit, at least for me, user-friendly in a way that I can easily define functions based on names. So if we, so this one is looking at the parent. I have to check if there even is, no, there's no custom. But if we would have a parameter called reset, I could just write in on reset pulse. And this one will then be called if the reset name, the parameter with the name is pulsed. So we can dynamically call functions, which in this case would look like this, if this is viewable. So because we are passing the name as a string, we can also use something like f strings or composition of strings to on the fly create the specific callback. Another case where it works quite well to your own callback or use a callback system is to wrap around existing parameters and bring in new logic or ways to work with them. So for example, with the queried web client component, which is a wrapper around, no, that's the license. Which is a wrapper around the web client. So this one allows you to basically create your own logic that fits more your style of working. So in this case, for example, I have different callbacks for when a response actually succeeds, but I also have a callback for when it errors out. And this is an older idea that I had and that I deployed in several components, is that I'm also have a way of like deploying stubs, so auto completion. So in this case, if we press this one and now open our thingy here, now we can, my mouse is doing interesting stuff. So now we have with request, for example, we have actual code completion, which I hope will change a lot with a way of packaging components that I want to propose. But this is something that we can talk about in the breakout rooms, if you're interested in that. So another quite nice thing is that, and this is something, it took a while for me to even realize it, because it's quite interesting, because Ivan is in fact already doing quite a lot of this. If you look at, for example, the lister component, which has a lot of this behavior also, is that you can change behavior or influence specific behavior of your custom operators and components without having the need to go in them. And you can do it in like the command, not command chain, but like in the flow of events and method calls that are brought in. So for example, what I do here is I have a callback. And in this one, I mean, this is like an edge case because it isn't really a callback, but it behaves quite similar to that. Then that I'm getting some information, some data from the component, and then I'm returning a data set of Python objects back into the logic of my extension. So this allows me to make this one, for example, a clone of like a master or primary routed web server, which I can update. And I will keep my custom behavior and my custom data as it's living outside of the component itself. A similar example is with the config component that I have here. So this is a component and it has a lot of logic, but it doesn't have any information about the config itself. All of the information about the logic itself lives outside and is defined in this specific callback in the getConfig schema. And also here, I'm passing a lot of information, a lot of modules already in, so that you don't need to fiddle around. It's plug and play. And again, like I can now update the JSON config component here without issue, because all of the important information lives in the file and lives inside of the callback. And the next cool thing is what you can do, which Ivan already showed, is you can create clear and distinct actions around existing systems and parameters and chops and other operators. So for example, this is like a really, really simple example where I just said, okay, I want to have a callback for on kick, on snare, on rhythm, because it's sometimes something that you want to have a specific event that you can then react in Python to. So for example, here I have on kick, I'm just updating the cache. I, of course, could have done it with chops. It's a very simple example. And again, this one is also just showing that's like one line of code. Because this is something that I will come to in the next one when talking about executes, is because we're getting a lot of information, these executes, they're not pure react to this, but they give me information. So for example, in this case, they give me a channel as an object. And the channel is not just the value, which is val, but it's a channel object, which you can find in the wiki. So we can just take the name of the channel and then we can capitalize it, for example. So this way, from the get-go, I already have, in theory, callbacks for on low, on mid, on high, on kick, on snare, on rhythm. But for the defaults, I just pass in on kick, on snare, rhythm. But this is a very powerful thing, which allows you to create and build components that you truly can reuse. That's the one thing. And what it also allows you is to keep them updated without fiddling with the insides. Because the moment you have to go inside of a custom operator that you build, it's built the wrong way. Okay, I'm really sprinting through you. Half point. Yeah, the hidden power of execute dats. I already talked a little bit about this, is that they give a lot of additional data and they give you pure Python objects. So you don't even have to do a lot of weird stuff. What I see, for example, sometimes when people build UIs is a setup like this. So you have a button, and for every button that I create, I have or like for every selection, I have a button. So I press this button and this simply loads images. But it's non-dynamic. It's very cumbersome and hard to set up, and then you have to change. And now if you suddenly want to change the behavior, for example, because I rename this operator, you're suddenly at a point where you have to go into every single chop execute and change this, which is not good. Two things: chop executes, or in general the executes, and a lot of other operators support pattern matching. So for one thing is, of course, you can filter channels, but you can also use pattern matching to subscribe to more than one chop. It says chops with an S. So for example, I could just say no asterisk, and now suddenly this chop execute is listening to all of these chops without having to manually put this in. Okay, where does this bring us? We now have, of course, the problem that there's a defined value. So here is my counter proposal. What this could look like is that we simply already have the button and we add a custom parameter and call this file. So now when I press these ones here, you see, it's showing the same behavior, but I can very easily just copy my button here. I think for this one I have to add more buttons here. So now it's also listening to this. So you see pattern matching. I could, of course, also just add the asterisk. So now I can go in here and I can select this file. And now when I press this file, boom, it's loaded. I don't have to go into any chops, into any elements whatsoever. It's all completely dynamic. So this lends itself very nicely, especially for UI building, but you can use it in several processes. So for example, if you use a replicator and dynamically the file parameter using references to a table, you suddenly no longer have to manually create anything there. You just have to update the table, or if it's an OP, like a folder that, then suddenly you just need to update the folder itself, and all updates automatically without any manual interference. Some people say, yeah, it's easier to read and easier to understand, but I say, yeah, but here is like there's specifically exactly one point where something is happening, and in Python, and we are only looking at this, and this is in general much easier to read. So we can kind of combine all of this into, I call it like the systematic approach, where we use, I think, yeah, for this one, I have to open this one. So I can press these containers here, and here we have like, this one just says click, and these two say clock clock, because they are listening to the same parameters, to the same callbacks. So what we're doing here is, again, we're just using pattern matching again. So it's container underscore and an asterisk, and this one will look for all of these containers. And then in here, what we're doing is we're just saying, okay, does we take the owner of the panel value, because again, the panel value is not the numeric value, the Boolean value that we're getting, but it's an object passed on by TouchDesigner that allows us to give us quite a lot of information, or take a lot of information, for example, the name. So we are listening to select and decide. So I'm made a little bit of dictionary stuff here because it looks slick and cool. And again, I'm composition, and I'm just taking the target name, which is the name of the panel value, so select or inside, and then I'm looking this up in our dictionary here, and then depending on if it's true or false, I put another name, and now we are in the end just composing the values in here, and then in our callback we trigger that. It's a lot, I'm understandably. But in general, I think what I really want to say is use pattern matching in the par executes and use the data that you actually get to its full potential, because I see so often that it's just like, okay, I have a fixed value in here, fixed value in here, and here I'm maybe using if par.eval and do something. But being able to like fetch the data and information from object is quite a powerful tool that makes a lot of stuff happen and much more. I'm wondering of, sorry. I think the last thing about callbacks in that sense is what's super important about callbacks is that you always pass a reference to the object that is calling the callback. So in this case, it's panel.com, but it's the same basically with par executes. You get the parameter itself as a reference that you can use. And the same idea is with the containers. Then if you have a container, like if you're building your own callbacks, then try to type them as much as possible. So this is at least what I'm trying here always is do type hinting. Type hinting is great. Type hinting makes all of our lives easier. 10 of 10 would recommend. So let's talk about events. Last one, I promise. So with all of this combining, it would be nice if we would have a simple way of defining a one-to-n relation, because we quite often have situations where we do have stuff happening in one part of our project, and we want to react to these changes and events on several spaces without influencing the core concept, like the core system. And this is where an event listener emitter system comes in. So quite similar already to the executes, which are in a sense already an event listener system. This is something which is surprisingly simple to yeah, okay, sorry. I mean, it's a lot of this is bridging. So the idea is that there is an emitter component, and in this emitter component, we are defining a set of potential events that can be emitted by this specific event emitter. So in this case, this is just like the default is on trigger, and then we have then we can pass some optional arguments, and then we can have any amount of listeners. So I can drop this event listener anywhere in my project and reference this specific emitter. And now when I say emit trigger and give it the specific parameter, then yeah, basically we will have the event as a callback. So this is why it's inside here is also just basically this is really just a callback manager in wrapped around a callback manager, wrapped around and wrap and everything wrapped and abstraction. So yeah, so we can just copy this one quite easily. So it would be nice though if there is a way of not having to reference the emitter, because the emitter then has to be inside of a component and so on. So what is the next step is being able to attach an emitter to an extension. So this is what's happening here. If we look inside here, there's quite a lot of other stuff going on because it's actually a already packaged component. But if we look in here, this one is really nice. So here we are just saying emitter attach emitter, and we are attaching this extension, and with this simple function we are now able to subscribe to this specific operator, like this component that we set up and built. And this allows us now to build some really interesting and cool systems. So for example, this one init procedure, this is something that I have basically in any project, which allows me to define a clear startup procedure. So on startup, there's just a timer inside that will run, and then it will emit an event for every time, like for every step of this timer. So it will emit on startup, on load project, on update remote, on open output. And then we can place in like different places of our project where we need it. So for example, media loading and like output alignment and stuff like this, we can everywhere place these event listeners, and then here we can create our callbacks. And as you can see already, it has like the on startup, load project, update remote. And if we add a new one, so give it a length and now create this one. Now we have the on foo here as also a callback. So this one allows us to decouple elements of our projects in a way where working on anything in our one part of the project doesn't influence like the primary part of the project. So this helps a lot with like decouple, like separation of concerns, as people say in programmer lingo. And yeah, this can go further and further. So for example, this one state machine component. And here we have different states, and we already have callbacks, which is nice. But callbacks are always in one place, but we want to react to the changes of the state. So again, we build this one. And here we are again with the dependable names. So this one is set up in a way where you can write on state enter underscore underscore, and then you can just pass it the name of the state that you are looking for. So if we check our thing, actually, let me just turn off this little noisy friend of ours because it's a little bit annoying. So now if we go to this state, then we have, okay, state enter generic A, entered A, exiting A, state enter generic D, because now we are in D. And I can react to this very specific, and this is what I said again, it's like this with the composition, we are able to define very clear and distinct points in our code where something is happening. We don't have to do like, if this, then that, elif this, the bum. No, we're just saying, hey, okay, on state enter underscore underscore A, and we have our state A action. Another cool thing that you can do with this is like a host setup, because sometimes you have situations where we are in a point of having one element in our project that it requires a single point of entry. So for example, with the Stream Deck, which I implemented using the Stream Deck Python library, which is, so you can see it here. So here we have a Stream Deck, and I can press this button, and you can see that it's happening here. If I would have more than one of these Stream Decks, we're suddenly at a point where when I would put everything of this into one component, we would be at a point where we would not be able to place more than one because the library is blocking all the ports. So what we can do is we can create like a host setup where we say, okay, we have like the core component that is creating the connection and taking care of all the signaling. And then inside, again, we have an event emitter that we are attaching to. And then we can, basically here in our Stream Deck component, which then represents the actual device, we are able to just select which device we want to listen to and react to. And here's just another example. It's from ZenTK, which is we are currently working on, which is a primarily network-based system. Because we can only listen with one UDP operator to a port, but we have a lot of different encoders and sensors that we can attach to it. Again, we have this the hub. So here in the hub, we are collecting all of our controllers, and then in the encoder, we can select our controller, for example, and which port, and then we get the events passed to our encoder. So in this case, this would just have to find the expose because I don't want to rewrite it up. So if we go inside here, you can see that we actually just have like a very simple event listener that says handle event and passes the ID of the controller that is sending the event, the port index, and the actual command data. And then in here, we're doing the actual filtering. Then we are again passing it to yet another callback manager. So it's quite a long chain of stuff, but this allows me to have these really easily deployable, rapidly deployable, and quite stable systems where I can say, okay, root of my project, dropping ZenTK, and then where I need it, I just drop in the specific sensor, reference it, say, okay, it's in this controller on part 12, and boom, done. Yeah, and it's basically the same here with the Stream Deck device. I think there was quite a lot. I talked a lot. Thank you.
Thank you. My head is fuming. I love how you said like, oh, this is surprisingly simple while showing like 10 different complicated scripts at the same time. But some of these components you were talking about, these are on your GitHub, or right? Am I getting that right? or are these just like custom things you
No.
build?
They are currently now, and so no, most of them are private components that we are using. So what I wanted to show much more is like the idea of how a relatively simple component like the callback manager can be used to increase functionality, and from that on, then because all of that functionality, what I showed you, is based on three components. It's the callback manager, it's the event emitter, and it's the event listener. And from that on, you can just think in whole other ways, which are not really native to TouchDesigner, which I was inspired on, like some of this behavior. I was inspired on doing a lot of web development for a while, because they have like this add event listener and then so yeah, that's currently the state.
Okay, cool. Thank you. I really love the execute based on the pattern matching. I mean, I'm familiar with pattern matching, but I've never used chop execute or whatever execute for several different components at the same time. So that's actually really it's a great tip.
An incredible, powerful way.
Yeah.
Yeah, I think we added that in about 8 years ago or so, based on some things. I'm glad people are exploiting it. And I'm really just amazed at how you're exploiting like the execute dats that are already there and kind of working around it and building things around it. So I'm kind of it's very hybrid.
Yeah, it's normally what I started doing. Like when I started working with Python and TouchDesigner, I was doing a lot of stuff purely in extensions, and I came to a point where it was really hard to work with other people, because they just couldn't understand and get a grasp of what the fuck just is happening at all. But it was also for myself, because as Ivan, data availability, very, very big problem that you have working purely in extensions, because it's really hard to understand where data stands and what is happening. So I try to find this hybrid, I call it like touchy, it's not touchy workflow, but like this operator-based workflow where everything is behaving in a way which is as close as possible to what TouchDesigner already is doing in many cases, so that I can give it someone who has an idea without having to be like, hey, okay, you have to go into this extensions, then change this value, and then you have to go in here. And no, it's like, okay, here's an operator and here's a callback, because you already know callbacks if you've used a timer chop once in your life.
All right.
So
I'd say we continue this discussion further later on, and move on to the last presentation.
Thanks, Ray. My name's Noah. I run a studio called Hardworkparty, where I make digital objects and installations and experiences with complex inner lives. I've been using TouchDesigner, I think, I'm going to say 10 or 11 years. I don't remember, something like that. I help run the TouchDesigner Discord. I'm trying to organize a Philadelphia TouchDesigner meetup. I have been organizing one. If you live in the area, please come by. I've seen a few of you there. For the last 2 years, I've also been running a startup called Third Wave, where we're building next generation immersive gaming experiences. I tend to talk too fast during presentations, so let me know in the chat if I need to slow down. So the drum I've been banging recently, and this is just one aspect of it, is trying to make the kind of node-based programming environment of TouchDesigner something that is easier to reason about, is easier to work in, is safer from like a correctness standpoint, is easier to collaborate with other people in. And one of the people that I would count in that collaboration picture is your future self. I think of my future self as an idiot who at the same time is super arrogant and will respond very negatively to every line of code that today me writes. So, from the perspective of code being a liability, I'm trying to get things as compact and as clear as possible, sometimes at the expense of performance. If performance is a big thing for you, I'm going to talk about that a little bit in here, what the impacts of my suggestions are on performance, but I will optimize last if at all. And I'm much more focused on legibility, maintainability, clarity, etc. One of my goals when I'm writing TouchDesigner applications is to make it so you or I in the today or in the near future could open up my application and get a very clear idea of what's going on within 5 minutes of opening it. So on top of that, there's some other benefits I'm going to be talking about. So without teasing it any further, it's already on the screen. I'm talking about a library, just a library. It's called Pydantic. This talk could be filed under the one weird trick category, because you're going to get 99% of what I have to tell you just by deploying Pydantic in your TouchDesigner applications. And it's going to be focused on why, not how. I'll show you how. It's really easy. But the three core themes that I'm going to be coming back to are you're getting types, you're getting type data, you're getting safety and validation, and you're going to get a little bit of a hit to your performance, but a huge upgrade in your dev speed and your safety and correctness and stuff like that, which is going to result in making projects that are just easier to work on. There's a lot of quotes about this kind of stuff. I had one in my head that I must have dreamed because I couldn't find it, but you can find a million flavors of this. Representation is the essence of programming. Bad programmers worry about code. Good programmers worry about data structures and their relationships. This one's from a little guy named Linus Torvalds, who knows a thing or two. Let's start with where you might be. Well, no, you know what? I'm going to skip this. I'm going to come back to that. When I say data, you might be thinking like data visualization, like charts and graphs. Not what I'm talking about. But, I mean, to a degree, that's what I'm talking about. But what even is data? Data could be anything that is an abstraction, anything that is like an idea that you need to represent in your application, any kind of concept, object, abstraction, anything, that's data. And so going back to what we're talking about here, if you begin your application by defining your data structures, by defining what it is you're talking about and what it can and can't be, you're 90% of the way there. So Python, and by extension TouchDesigner, is duck typed. TouchDesigner has types outside of the Python interpreted part of TouchDesigner, so that's not entirely fair. But in the Python part of TouchDesigner, no fault of TouchDesigners, it's duck typed. We have type annotations, we type hints, we have kind of nice to have, we have ways to bolt on some effort to get the TouchDesigner to or Python in general to use types in a stricter way, but it's not a strictly typed language. And what we mean by duck typed is if we figure out the type of something. If it walks like a duck, if it quacks like a duck, it's probably a duck. That's not so great. I might be trying to pass a value from one place to another. This value being, in this case, we can tell by the name of the attribute. It's a name, and who knows what's in there, right? I mean, notionally, it's supposed to be a name, right? We see that, and that's where a lot of people are going to leave it. I'm going to encourage you to do a little bit more than that, because it could be all kinds of things that are not so good to work with when you go to actually put them in practice in your application. You might be working like this. This might be where you are today. And I'm here to argue this is not a good way to work. This is not meant as a shot at anyone's style. I'm not in the nodes. I've said it before. And especially when it comes to business logic or handling data, chops are a different story. I think this is what Ivan was talking about. If you're trying to do something high performance, sure, chops, absolutely. That's what they're for. Audio, what have you, anything high performance. But when it comes to actually parsing data, doing business logic, trying to make decisions, I try to get out of the nodes as fast as possible and get into something that I can read in an IDE, that I can diff, that I can check in version control, that I can externalize. I just want it out. Again, don't feel bad if this is what you're doing right now. You may not agree with me at the end of this talk, and then you're going to feel great about what you're doing. But I think we're led to believe by the proliferation of nodes and examples of using those nodes that manipulating data in TouchDesigner using DATS is a good idea. I don't agree. But even if you graduate to using Python scripting or extensions at some point, hopefully soon, I guess I'm preaching to the converted here, but you're already listening. You're not the choir yet. You may not even be the converted. I'm going to preach. Use extensions. In TouchDesigner, it's absolutely the norm. I see it all the time, to pass untyped whatever from place to place with zero schema. Maybe you're using some type hinting, but just slinging dictionaries all over the place and just kind of hoping, right? And then this may sound familiar. You're going into a dictionary of values, and you're every single time you reach for what you think is a key in the dictionary, you might be accessing it with get and then checking against whether the result is none. That's exhausting. Incoming data from OSC, from MQTT, from APIs, REST endpoints, whatever. It could be anything. It could be absolutely anything coming in. Just because it's upstream of you doesn't mean you can trust it. Definitely because somebody else wrote it doesn't mean you can trust it. And one bad key, one missed validation that you're supposed to be doing at runtime could crash a show in front of your clients, or could just result in like let's say you have a meter and the meter is going the wrong way. The meter's supposed to go, well, is my camera reversed? I don't know. But let's say the meter's supposed to go like this, and you're looking at it and it's going that way. It's going outside of its bounce the other direction. And it's getting clipped by the box that it's in. And you're like, why would that go backwards? That's a meter of things that go up. I'm here to tell you it doesn't have to be like that. This is a guy holding a squid. So you might say, like, I love not worrying about nerd stuff like validation and types and correctness. I don't think that's you, again, because you're here for this talk. And you might be saying, I'm a free spirit. Like, don't kill my vibe. But despite the fact that they dropped the FTE from the name, I'm here to tell you that TouchDesigner now, with all the extensions and the tools I'm going to show you today, is way more of a free thinking environment than it ever was before. So don't worry. We're going to get our facts straight at the door. We're going to get our stuff right. And that's going to free us up to work on the parts that we all care about the most. So now let's actually look at some code. I'm not going to be running TouchDesigner, as you can tell here. I use this. There's these cool tools where you can format your Python so it looks good in a slide. So I'm doing that. Okay. What do we get with Pydantic? We get a declarative model. We get a schema. We get a parser, a validator, and we get serializer all in one spot without doing any extra work. And it works with built-in types. As you can see with this example, we're using, I think I have a laser pointer. Let me see if this is going to work. Yes. We're using annotated, literal, and list. These are all coming from the built-in Python typing library. And I'm just giving you an example here, like, because I'm working on games, so this is all going to be game kind of related stuff. We have this player here. They inherit from the Pydantic base model. We imported this from Pydantic. This is pretty much all you're ever going to need to do. And it's got these fields on it, right? It's got these attributes that are the usual stuff that you might see on a player object. We got a username, we got a role, we got an age, we got a score, we got an inventory. But these have validation that happen at the time that we instantiate the object. The username has to be between 3 and 16 characters. The role is a literal. This comes from Python here, but it's got to be a kaiju or a defense. I was making a kaiju game. The age, very generous age range, I think, especially in the, this is a gosh, I hope somebody 120 is going to play this game. Score is not validated. We'll come back to that. And neither is inventory, and we could work on that too. But what we get with this, Discord closed. Did it crash? No, I'm still here. Oh, I have Discord automatically hide periodically. I'm back. Hi, everyone. So yeah, we get this object here. We got this player thing. What does this do for us? Okay, it's going to validate at the door. So I'm going to give you an example of like writing a field validator is what it's called for that score. Really decorator here, and we're going to tell which field we're validating. It doesn't have to be a class method. Just put it there. It's a V2 thing. Okay, and then we're just going to say the score has to be non-negative. So all we're doing is we're saying if that value that's passed into this validator, it passes in the class too. You guys are familiar with class methods now because you've been looking at extensions all day. We're going to raise a value error. And that value error is going to say score must be positive. What this does is if we try to make a player object with a negative score, we get this error. We get this very clear error that gets raised, and we can handle it. That doesn't happen later on when I'm trying to put up a score meter or something like that, and all of a sudden I see a negative number. That just can't possibly happen in my application. Cannot happen any further. Can't happen. No, all those errors are gone forever. It'll never happen. Same thing with like the username having, and I'll show you some other validators, the username being too short. I know that the username is going to be between 3 and 16 characters because that's what I said. Thank you, Wieland. It will never happen. It's a great question. Thank you for asking. All right, so this is where raw JSON potentially becomes structured Python. All right, I'm going to show you a structure for doing this in TouchDesigner, but this is like a validation firewall. And this gives you a clean separation from the untrusted world where your data is coming from outside of the box. Yeah, it'll never, thank you. Yes, in Vegas, it'll never happen. The data comes in, by the time it gets in through the validator, it's safe. And now you can let your other comps, your other code in TouchDesigner run wild and not be doing all the dereferencing and checking inside of your application. This is especially helpful, obviously, in multi-comp projects where each comp has a single concern. But if you're doing something, yeah, I got exactly. But if you're doing something where you have like a bunch of people collaborating, you could delegate one developer in your team to dealing with outside data, dealing with the server. They're going to do the validation, and then I'm going to show you in a moment, we're going to hand around safe data inside the application, and nobody else has to worry about it any longer. So just as kind of like a cartoon version of this, communication comm is our comp that talks to the outside world. Who knows what's in there? It's going to fling its stuff along to data where it gets validated, and then from then on, the whole rest of our application is good to go, safe data. So here's what that might look like. And again, sorry to kind of do the cartoon version of this, but I think it makes it easier. Imagine in that comp, we have this method called fetch raw player data, and it's just going to hit an API, and that's going to come back as JSON. So we're going to return that JSON as a list of dictionaries. Great. The conductor calls that. Okay, we're going to request players in the conductor. The conductor is the brains of my application. It's the only one that knows what everybody else's API is. It's the only one that knows what's actually happening in the app. Everybody else is dumb. So it calls comm, it says fetch raw player data, and we're going to get back this list of dictionaries, which we're going to pass into parse players. Parse players accepts the raw players as a list of dictionaries, and then it does this list comprehension. All it does is on the player object, on the player class, it calls model validate. This is built into Pydantic. For every JSON dictionary, for every object in that raw players list. And what it's going to send back is a list of players. And that's what's going to come out here in self players. That's it. Our stuff is validated, done. If I want to change the rules about how the validation works, I just go back and do that in the class definition. None of this stuff changes. This is like boilerplate. What else does that get us? Well, and furthermore, I just want to, if at the time that we're building up these player objects, this list of player objects, there's a problem, I'm going to get a very nice, very clear error about it. I'm not going to get something that's like none type, yada, yada, who knows what happened. It's going to tell you exactly why your data failed to validate according to the rules that you've defined. I probably should have put some examples of these errors. Believe me when I say they're very clear. There's no mystery when you get one of these, and they're not errors, they're exceptions, obviously, so you can handle them as they come up. Because maybe there's some situations in which the show must go on, and you want to just do something smart with, oh, right, this API sometimes returns a negative age, and that means blah, blah, blah. So I'll make an annotation or whatever. I'll change a flag on something. Okay. Another thing that's really nice about this is that now that we have this validated object, we can use it as a data transfer object between our comps inside the application. So just remember that we had this kind of cartoon layout here. We've got a comm to the server. We got data that does the validation and warehouses data for the rest of the application. And we've got a conductor. In our conductor comp, we might say start game. And so start game, here we go. We're going to this is the same thing we just saw before. We're going to parse players. So now data has inside of it this local players object, local players member. It's a list of players, right? Okay. And I'm gonna put this on data. I'm gonna say get my players, and it's the return type is gonna be a list of players. Okay. I'm gonna call stats, and I'm gonna say calculate high scores on data's list of players. And then here we go. We got a one-liner here where we're just going to sort our players by the score attribute. If I try to, now one of the beautiful things that you get with this is, and you get this with base classes with data types in Python or just using the built-in typing library, but this right here will throw a squiggly underline warning in your IDE if you're working in an external editor. If this is not a key on the player class, you're going to catch that right away. This would actually I don't want to overpromise, but in my experience, if you're using like Cursor with Cursor tab or like any kind of AI autocomplete, by defining your primary data objects centrally in your application and then opening your application, opening your whole project folder in your IDE, this would all write itself. I could write a comment at the top that says, start game, fetches raw players and then parses them into players and then calculates high scores. It would just write all of this. Because if you look at this, we're not doing anything except poking this player object a little bit. That's all we're doing. And this is coming back to that quote from the beginning of the slideshow, which is like, all of this programming is really just about this underlying data. Now, I'm obviously focused on business logic. I'm not like writing shaders, to make things look whatever blurry or something. That's not what I'm not what I'm doing. That is also manipulating data, but I'm really focused on business logic here, that stipulation. But what we get with this data transfer object that we're doing, or the use of the player as a data transfer object, is all these APIs that these components are exposing to one another are completely self-explanatory. The player is a safe, validated way to just toss the data from one to the other, and the operations that they're going to do on them are very obvious. You can also run, something like MyPy on this to do static type checking as well, and you're going to get that nice clear error there as well. All right, so I mentioned serialization and schema. These are both built into Pydantic as well. You've got this model dump JSON method, which you could just be handing this right to WebSocket tab. This is going to just dump out valid JSON from your object. And you could also be saving, if you're serializing your disk as JSON, just boom, just like this, just dump JSON and, with open my file as blah, 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 F, model dump JSON, boom, just write it out. Same thing when you want to read. It's very easy to just validate right off of JSON on the disk in the reverse process. And then model JSON schema, same thing. It's going to put out a JSON schema. You can hand this to Swagger, OpenAPI, your REST endpoints, whatever, you define all this stuff right off of your data model, and those things are going to stay in sync. So one more nice little thing I'm going to show you real quick in TD world is if you're using M files to set environment, these might be things as you can see, like your resolution or which the name of your workstation is, or maybe a path to assets on disk or whatever it is. You're putting these in the M file, and then probably you're loading them up, and maybe you're doing validation on them yourself. There's a built-in thing, Pydantic, for this. It's called base settings. You just inherit from base settings and tell it where the end file is, and it's going to go validate that the data in your end file is what the type you say it should be. And then after that, you can just grab it off of this object that you've created. Really simply. If you don't use the end file, if you do not call this part right here, what it's going to do is just look in your environment variables, but it'll validate them. So once again, you're not just spraying and praying and hoping like, I hope that's a number, I hope that's a 0, whatever. Like it doesn't have to be like that. So this makes it really easy to have different configs on different boxes, to collaborate with different developers, etc., but to still have centralized validation where you say like, I'm going to go handle this value. This is going to go into the resolution of a render, like that better be an integer, etc. All right. Performance. Is this a fair comparison? I'll leave that to you. This is not validating. It's 0. Costs nothing to not validate. But what's the real cost to you and your sanity? Don't worry about V1. I don't know why I have this in here. But I ran 100 or I think 1,000. This is an average. I ran this with a big, ugly Pydantic model and validating it. And it took 215 microseconds. You have 16,000 of those to get 60 FPS. It's not nothing to validate. You might not be doing that validation every tick or not. Hopefully you're doing that strategically. But you do want to think about it. So you might want to like run a benchmark on your shapes and just make sure, you can afford to do all the validation that you need to do, or maybe you want to offload that to something that's not in your core thread, in your main thread on your application. Okay, so some gotchas about this. By default, these do not behave like data classes in the sense that they are not frozen by default. So if I were to create a player with a score of 0 and then try to assign to that score, that's going to work. Now, I mentioned earlier that these are great data transfer objects. You got to be careful about that, right? You know, if I'm referencing the same player object in multiple places and I'm manipulating it in some of those places, I would call that a side effect. All right, so be aware that that's going to happen to you. Sorry, this is still comment wrapping around here. My bad. But if you say frozen true on this, then you'll get a nice type error when you go try to change that value. Also, arbitrary types. I see you guys talking about NumPy in there. If you want stuff like NumPy, it's not supported in Pydantic. You could call arbitrary types, or you could set arbitrary types allowed true in your class. But if you do that, then it's not actually validated. So you need to roll your own validator if you're going to be doing that kind of stuff. It's as simple as this. It's just doing like just check if it's an instance of the thing that it's supposed to be. This is what it's doing under the hood. Just you have to do it yourself because it doesn't know what that class is. In TouchDesigner, this is the best. This is actually the house slide. This is the best way I've come up with to do this. I feel like there's got to be a better way. So hopefully I'm going to find out today. What I do is I have a text file on disk that is my Python classes document, or more than one. This is set to sync to file. You know, it's a text stat and it's set to sync to file, so it's in sync everywhere in my network, but I drop it right next to any of my extensions, and I'm just gonna bring in the classes that I want right here, because from classes, and this is called classes, you can see this little line happens here. The problem is if I modify this, sometimes I have to bump these extensions. I have to reload the extensions, so that's not perfect. And also, you know, you got to remember to drop this thing in, although it's pretty trivial. So, you know, this is the pattern. This is it. You know, aside from if you need to bundle, you know, you got to add Pydantic to your site packages, you know, which out of scope for this talk, but you got to do that too. But after that, you're off to the races here. And here's some bonuses real quick for you. Pydantic also includes email, IP address, color, et cetera, built-in types that have their own validators on them. So if you're handling these things with any regularity, boom, you've already got them, they're already valid. In addition, you can do computed fields. These are going to look a lot to you like properties in the sense that this is a getter. At the time that I go to reach for this, this is a property on HDR color class here. And it's computed off of the RGB 16-bit value. Is that right? It should be. Yes. There you go. Sorry. Discord closed on me again. I'm back. Hi. So what I'm doing here is I'm just clamping this. Doesn't matter what the math is. But the point is, if I reach in for this normalized RGB value, I'm going to get back a computed value at the time that I reach for that. And that's what properties do, right? It's the same thing. The difference is with Pydantic computed fields, those are included in the model dump, in the schema, in the JSON dump, et cetera, and they are not in properties. So this automatically extends your class with a computed field that shows up everywhere you would expect it to, which, again, very nice. Takeaways. It's typed, it's safe, it's probably fast enough. Do it for the children. Thank you.
Thank you. Thank you. Wow. That was, again, a lot of input. But thank you for that overview. So basically, it's a free library we can all get now, or yeah.
Yeah, that company Pydantic have two other really cool projects I would recommend everybody check out. One is called Logfire. It's a hotel like observability service. Your first like 1 million records a day or free or something. I mean, it's like very, very generous free tier. Thank you. Ugins posted it there. It's kind of a Sentry kind of thing, but you can like decorate chunks of your code with these spans and then see. It's kind of like the activity monitor in TouchDesigner, but for Python code. Very helpful and gives it links into Pydantic, so you get these Pydantic objects that bubble up into your observability, and so you can see exactly what the state of your application was at the time that something went wrong. And it's a graph-based AI agent tool that is, again, has Pydantic under the hood. It's all validated and stuff like that. So it's a very interesting way to get series of events to happen through very, very unreliable LLMs, such that you can trust what's happening to some degree, a little bit more than just asking LLMs for something.
You've been able to use that in TouchDesigner?
No, I've not tried yet. I'm working on a project right now where another developer is doing the whole Pydantic AI lift, and it's pretty cool. I mean, I don't have the appetite to write an agent, but if I did, that's how I would do it.
I'm still hung up on the guy holding a squid that you jumped over.
It's by an artist named Brandon Bird. I recommend everybody check him out. That's Michael Landon from Little House on the Prairie, and the painting is called The Anguish.
I see. Thank you. Cool. Yeah, we'll stop the recording.